Hi, let's continue with this fourth presentation in our foundational series. In this discussion, we'll be looking at how we translate an English phrase to an algebraic expression. So very often, the source of the problems that students have with mathematics is not mathematics, it is English. And this shows up very often when students are trying to do word problems, and you always hear students saying that they hate word problems. So let's try and practice a few of the elements that are involved in solving word problems. Now, these phrases are not to be memorized. I mean, if you feel like you must memorize them, go ahead. But just become familiar with these things and try and, read more often if you don't read enough, and just build up a good command of the English language, and I guess do more mathematics courses. Yeah. Anyway, so let's look at this, right? How many ways can we say addition? Sometimes you're given a problem and you are not told explicitly to add two things, but just from the language you know that you need to add these things, man. So for example, you can hear things like a plus b, the sum of a and b, but you may also be told that a is increased by an amount b, or b more than a. The new amount is b more than a. The total of a and b added to a. Likewise, for subtraction, you hear things like a minus b, or the difference of a and b. So this word, the difference, sometimes students find that like strange, and that should not be the case, but often, well, I shouldn't say often, but sometimes I've found students finding it strange. The word difference means subtraction, right? So the difference of a and b is a minus b. You could also say a is decreased by b, in which case you know then that to find out the new value, it's going to be a minus b, or b less than a, or b subtracted from a. Likewise, for multiplication, it's a times b, or the product of a and b. So be aware of that, right? We often say the product of a and b. In the case of when you're just multiplying by 2, you can say twice, But that's this is very limited. Likewise, for division, we can say a divided by b. We can say the quotient of a and b. So be aware of this. The quotient of a and b, the ratio of a and b, or we can say b divided into a. So let's take a look at some examples. We are asked to translate each of these English phrases into algebraic expressions. So the first one we have here is the difference of 14x and 9. Well, obviously this becomes 14x minus 9. The quotient of 8y squared and 3. That's 8y squared divided by 3. 12 more than y. Well, that's y plus 12. And 7 less than 49x squared. Well, that's 49x squared minus 7. Here are some more. 8 times the sum of x and y. Well, you have the sum of x and y, and it's 8 times that. The sum of 8 times x and y. So it's the sum of what? This and this. So it's 8x and y. So see the subtle difference here, right? Here it's 8 times the sum of x and y. The sum of 8 times x and y. It's the sum of these two things. This one, 8x, and this one, y. The length of a rectangle is 14 less than the width. So 14, whatever unit, feet or inches, we're not focused on the units right now. It's just that it's 14 less than the width, whatever the units are. So let W represent the width of the rectangle. Write an expression for the length of the rectangle. Well, the length is 14 less than the width, so you have to subtract 14 from the width to get the length. And see, it's this what we have here. So make sure you can do this. And here's the last one here. So again, students find these very hard, and just take your time. June has dimes and quarters in her purse. The number of dimes is 7 less than 4 times the number of quarters, right? It's 7 less than something. What? Well, 4 times the number of quarters. And if Q represents the number of quarters, well, then it's 7 less than 4 times Q, right? So 4Q minus 7. Right? So the number of dimes is 7 less than something. So it's something minus 7. What is that something? Well, it's 7 less than 4 times the number of quarters. So that's 4Q if we let Q represent the number of quarters. So that brings us to the end of this little presentation here. So This should give you enough to do the assignment. Bye for now.